Okay, moving on now to oxidation and reduction. So oxidation and reduction reactions is one of the ways that we can classify chemical reactions. Remember, we have our 6 basic types, and oxidation and reduction reactions, what is called redox for reduction oxidation. Redox reactions is not one of our 6 basic types. However, 4 of our 6 basic types are redox type reactions. And remember that oxidation reduction, redox reactions, what distinguishes them is that electrons are being transferred in these reactions. So oxidation and reduction reactions are processes that take place in which the oxidation states change. Oxidation states change when electrons are being transferred from one species to another. Reduction is when an element gains one or more electrons. And when you gain negative electrons, you're going to become more negatively charged. So when we say reduction is gaining electrons to become more negatively charged. Oxidation is when an element loses one or more electrons, and since electrons are negatively charged, when you lose negatively charged electrons, you become more positively charged. So this is a little bit challenging to remember. So we have a little memory aid here, oil rig, O-I-L-R-I-G. Oxidation is loss of electrons. Reduction is gain of electrons. So oxidation is loss of electrons, and reduction is gain of electrons. Okay, oil rig. When we're talking about oxidation-reduction reactions or redox reactions, we're going to keep track of where the electrons are by assigning oxidation numbers. And then as the reaction takes place, we're going to compare the atoms on the reagent side to the product side and see whether they're losing electrons or gaining electrons. So here we have a sample problem. This is a typical sort of a problem that you might encounter for redox type reactions. It says in the following balanced reaction, oh goodness, they've already given me a completed and balanced chemical reaction. Isn't that nice? Assign all of the oxidation states. And then it's asking me some questions about them. So let's assign these oxidation states. Here's zinc. It's neutral elemental zinc alone by itself, 0 charge, so its oxidation state must also be 0. Copper 2 chloride, it's an ionic compound. I'm going to split it into its ions. And because these are monoatomic ions, it makes it obvious what their oxidation numbers are. Zinc chloride, same situation here. Ionic compound, break it into its ions. And I can see very easily, without doing any calculations, what are the oxidation states. This is elemental copper in its elemental state, 0 charge, so it's 0 oxidation state. All right, so I've done the first part. I've assigned all of the oxidation states. And now I would like for you to take note of what's happening to some of these oxidation states. The zinc started out as a reagent with an oxidation state of 0, and it ended up with an oxidation state of a +2. So I'm just going to draw this little line here to show you that zinc increased its oxidation state from 0 to +2. Well, we set up here that oxidation is when an element loses one or more electrons to become more positively charged. So that's what's happening to the zinc. The zinc has lost 2 of its electrons. Electrons are negative, so when it loses those 2 electrons, it has become more positively charged. So lost 2 electrons. And the term that we use for when a species loses electrons, we say it's oxidized. Okay? The next species, let's take a look at this copper. This copper starts out as a cation. It has a +2 oxidation state on the reagent side. And on the product side, it has an oxidation state of 0. It's elemental copper. So this copper seems to have gained electrons, gained negative electrons to become less positive. So gained electrons. And the term that we have for that is reduction, is when an element gains 1 or more electrons to become more negatively charged. So this copper gained 2 electrons, and therefore we say it was reduced. Notice how its oxidation state reduced from a +2 down to a 0. So with that in mind, we can answer a couple of these questions that are being asked. Which element is being oxidized? Well, the element that's being oxidized is the zinc. Which element is being reduced? The element that's being reduced is the copper. Now, I will tell you that it's a little bit of a challenge for our brains to remember that reduction is when we gain electrons, because electrons are negatively charged, and that makes the oxidation number reduce. And oxidation is when we lose electrons, and because we're losing negative charges, we become more positively charged. So oxidation, the oxidation state increases. Reduction, the oxidation state reduces. Okay? So this leads us to 2 more concepts here. Which species oxidizes the other? And this is called the oxidizing agent. And which species reduces the other, called the reducing agent. So let me explain what I mean by an oxidizing agent and a reducing agent. First of all, an oxidizing agent and a reducing agent have to be a reagent. They have to be a reagent. So the oxidizing agent is the reagent that caused some other species to be oxidized. So we ask ourselves, what was oxidized? Well, it was the zinc that was oxidized. So what was the oxidizing agent? It was the other reagent that caused zinc to be oxidized. So the oxidizing agent is this reagent right here. It's the copper 2 chloride. Because the copper 2 chloride was the reagent that caused something else to be oxidized. So which chemical species reduced the other? And that's what we're calling the reducing agent. So we're going to look at a reagent, and we're going to find out which reagent was the reducing agent. So we're going to look to see what was reduced, and it was the copper. That was reduced. And then we look to the other reagent, and we say that reagent caused that to be reduced. And therefore that whole reagent right there is our reducing agent. So in this case, it's the zinc solid. The zinc solid is our reducing agent. Now, some resources that you may consult, textbooks and online websites, they may want you to be a little bit more explicit about the element being oxidized. So they may want to know not only the element, but also in which species. So for example, they would want us to say the zinc in the zinc solid reagent, and the copper in the copper 2 chloride. And they do that because in some reactions it may be possible that the copper, for example, occurs in more than one reagent, and so they want you to specify which copper we're talking about. So just a quick review. Which element is being oxidized? Oxidation is loss of electrons to become more positive. The zinc is being oxidized. It lost 2 electrons to become more positive, a +2 oxidation state. Which zinc? It was the zinc in the zinc solid. Which element is being reduced? The copper was being reduced. It started out as a +2. It gained a couple of electrons, which made it become more negative, and it was reduced to a 0 oxidation state. Which copper? It was the copper in the copper 2 chloride solution. Which chemical species was the oxidizing agent? It was the reagent that caused something else to be oxidized. So it's the whole reagent formula, copper 2 chloride solution. Which chemical species reduced the other? That is, which was the reducing agent? It was the reagent that caused something else to be reduced. Now notice, none of these answers is a product. When we are saying what is being oxidized, what is being reduced, what is the oxidizing agent, what is the reducing agent, we never answer with a product. Why not? Because the products did not exist when this reaction began. When this reaction began, these 2 species did not exist. And so they couldn't be doing any of this. So the answers to all of these have to come from our reagent side. Okay, I've given you one more practice problem. This will bring everything together. It will include some of the calculations for our oxidation states. So I would like for you to pause the video now and see if you can do this whole problem all the way through. And when you're done, you can restart the video and I will work through it for you. Okay, coming back from pausing the video, taking a look at this equation, it is already balanced, completed and balanced, so that's great. We don't have to do any of that. So it says, identify the species being oxidized and the species being reduced. Also identify the oxidizing agent and the reducing agent. So it's these 4 questions. I have to answer these 4 questions. To be able to answer these 4 questions, I have to know what the oxidation states are up here, because it's only by looking at how they are changing that I can answer my questions. So even though it is not specifically stated in the problem, I am still going to have to assign all of my oxidation numbers. So here we go. Assigning oxidation numbers. This is not an ionic compound, so I have to do some calculation. Which is more electronegative, carbon or hydrogen? Hydrogen is 2.1, carbon is 2.5, so carbon is more electronegative. So I'm going to pretend that carbon is an anion just for the purposes of this math. Now if we look at our periodic table, we will see that if carbon were an anion, it would have to gain 1, 2, 3, 4 electrons. So it would become a carbide anion at a -4 charge. We haven't seen that very often. So carbon here with a -4, I know that's going to be my -4. If the carbon is a -4 oxidation number, and overall this whole CH4 molecule is neutral, that means that these 4 hydrogens must balance out with that -4. So each of these 4 hydrogens must be a +1. So that I got 4 plus 1s that will balance out with that minus 4. Are these charges? No. They are just a pretend charge that will allow me to assign oxidation states. Moving on to the O2 gas, the oxygen gas. This is elemental oxygen. It is neutral oxygen. So the two oxygens must have oxidation states that sum up to equal 0. They're identical oxygens, so each of them must be zeros. Carbon dioxide. Oxygen is more electronegative than carbon, so we pretend for a moment that each of those oxygens is an oxide ion with a 2- charge. If I have two negative 2s, then that carbon must be a +4 to balance everything out, because overall the CO2 is neutral. And here we have water. Overall neutral, so the sum of all the oxidation states must add up to equal 0. Between hydrogen and oxygen, oxygen is more electronegative, so I pretend that it's the oxide ion. So I have a -2 oxidation state for the oxygen, 2 of these hydrogens in each of these formulas, and I'm not worried about the coefficient. The coefficient just tells me how many of these species overall I have. I'm just looking at the formula. So 2 hydrogens have to balance out with that -2 oxygen, which means that each hydrogen must be a +1. So now I have identified and labeled all of my oxidation numbers. Now, which element is being oxidized? Remember, oxidized, O-I-L-R-I-G, oil rig. Oxidation is loss of electrons, and when you lose electrons, you become more positive, right? So which element is becoming more positive? My carbon is going from a -4 to a +4, so it looks like my carbon is being oxidized. So it's carbon. And let's be really specific. Sure, there's only one carbon over here on the reagent side, but we'll get in the habit of being specific. It's the carbon in the CH4 gas reagent that is being oxidized. Which element is being reduced? RIG, reduction, is gain of electrons. When you gain electrons, you become more negative so that your oxidation state is reducing. So which oxidation state is reducing? Well, the hydrogen starts out as +1 and it ends up as +1, so it's not the hydrogen. Notice what's happening to our oxygen. It started out with an oxidation state of 0, and over here it's a -2. So the oxygen is being reduced. Specifically, which oxygen? It's the oxygen in the O2 gas reagent. Oxygen is being reduced. Okay? Now we ask ourselves, which chemical species is the oxidizing agent? That is to say, which reagent caused something in another reagent to be oxidized? Well, if carbon was being oxidized, then it must have been the other reagent that caused it to happen. So our other reagent is the O2 gas. And by the way, this is where we get the term oxidizing agent from, and oxidation, because the most common and most well-studied oxidizing agent is oxygen, which is why we got the term oxidizing agent. And then we come to our last question, which chemical species is the reducing agent? So we find what was reduced, and we look at the other reagent. So the CH4 gas must have been my reducing agent that caused oxygen to be reduced. So it's the CH4 gas. Okay, so that is how to determine the oxidation numbers for all atoms in a species, and then to use those oxidation numbers in a chemical reaction to determine which element is being oxidized, which element is being reduced, and which chemical species, which reagent is the oxidizing agent and which is the reducing agent.